Okay, we're ready for worksheet 6D on the Math 4 course. A little attempt at statistical humor there on Mr. G's part. Now, today we're going to look at a spreadsheet that has data about our U.S. presidents. Something that, this was something that we had found. Ms. Vines and I are the ones teaching Math 4 this year at Enloe. And this is the first time that Math 4 is being offered. So we're kind of plowing through new ground on this, so to speak. And we had inherited a spreadsheet about the presidents, but it stopped at Trump. It was not current enough to have Biden. And so we needed to retype it as a spreadsheet. And so Ms. Vines made sure that Biden was included in it. Now, we did this in one of my classes, and someone points out, Mr. G, aren't we missing a president? And somebody finally figured out that, remember, there was a case where you had a president back in the 1800s, I forget which exact president it was, that he got voted in for one term and he got voted out. And then he got voted back for a second term, and he did split terms. There's only one president that's done that. But he would be considered separate presidents in each case. So that's why we have 46 presidents, but only 45 names. So some folks had to kind of think about that and ask themselves, what do they know about the situation to explain a seeming discrepancy?
Stephen Grover Cleveland.
All right, Grover Cleveland, Mrs. G is telling me.
It was the 22nd
and the 24th president. Thank you, Mrs. G. My shell answer man. All right. But anyway, so we've got the spreadsheet, and we're also going to open up CODAP, and we're going to dump it in CODAP and play with it some. So that's where we're going with this. So I'm going to line that up first, and then we're going to jump over here and all right, I clicked over to my page and realized that I hadn't opened any of those tabs yet. So this is the spreadsheet of the presidents. And one of the first things, well, first of all, we got to get it into CODAP. And so I have since figured out that there are actually two ways you can do that. One is that you can download a copy of this and then drag and drop it into the CODAP, into the middle of the CODAP page. Or you can, and I'm going to me, this is the easier way, I feel like, is that when I click the upper left corner of the spreadsheet, I highlight everything, and I mean absolutely everything on the page. And then I'm going to right click and copy from that upper left corner. Now I've copied everything on this spreadsheet onto the clipboard in my device. So I can go over to CODAP and try CODAP, and we're going to create a new document here. And so I've got this thing copied onto my clipboard. I can go up here with the icons and click on tables and open up a new table. And under ruler, there's a place where it says import case data from clipboard. Oh, I've already got it pasted on my clipboard, so I click that. Yes, I'm going to replace the existing data set with the new one. And there are all of my presidents. So I've got my data set ready to go. Now, I will say that, if we're going to start playing with graphs, and so we're going to, create a graph on something, then I need to go here to my data set and switch to case card view so that I can see what all of my categories are. Now, the thing we're going to start with was birth state. Now, originally, I first tried this the first time in class. I tried it this way. And I said, all right, and the best we're going to get out of this is what looks like, a grid of states and presidents. And, you're kind of on your own to do that. And then all of a sudden it occurred to me, you know, the questions that are asking, by and large, I don't need to know the names. I'm going to remove that. And I'm actually going to take the birth state and I'm going to drag it down to the x-axis so that it goes that way. And now I think I can do some more things with it. I'm going to scooch that back up. And I can go to the graph bars and fuse the dots into bars, create a bar graph. As a matter of fact, I can even go up here and put a count. And it shows me exactly how many presidents were born in that state. So now we can start making the comparisons. We had more presidents come out of Virginia. Then Ohio was next. Actually, that one surprised me a little bit. You know, Virginia, New York, Massachusetts, they were all original colonies. And, you know, it took us a while to expand to other states. So I was sort of thinking, but I guess maybe Ohio was one of the earliest of the states. But in any case, you know, now we can start answering the questions that they've asked us. So for starters, which graphical display would be best use for organizing the birth states? And, you know, we've done a bar graph here. Now, you know, when I try and look here, I don't have the option of doing things like standard deviation or box and whiskers plot. Those just simply aren't an option, simply because of the way that everything is set up. So, you know, bar graph has got to be it. So, you know, when we say, you know, which graphical display, we'll say bar graph. Oops, gotta turn the pen on. Bar graph of birth states. Okay, and we could even say with count. Now, which state represents the mode? Let's go back here and see. I see an awful lot of ones. As a matter of fact, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 states have had one president come out. And that seems to be the mode. So we can say 13 states had one president. Which state represents the mode? Well, that's just it. 13 states had one president. How do you pick one? You can't pick one state out of that and say that this is the one that represents. You know, you had 13 different states that had that same number. So that's as close as we're going to get to answering that. Now, which had a relative frequency of 11%. Maybe if we change this from count to percent, there's our 11% right there. Virginia was 18%, but New York is 11%. So we can say New York had 11% of presidents born there. Which presidents were in North Carolina? Now what you're going to wind up doing here is hovering on that. And you might have to, you know, without going back to the original data set, one thing that you could do was to unfuse the bars. And now I can see individual ones. There's Polk and there's Andrew Johnson, not to be confused with Lyndon Johnson. Andrew Johnson and Polk. So those are our two presidents born in North Carolina. Andrew Johnson, he was the guy that took over when Lincoln was shot. And yeah, he was also the only other, well, he was impeached. Clinton was impeached, but he wasn't found guilty by the Senate. And then Trump has been impeached twice. and he has yet to be proved guilty by the Senate. They're working on the last one, but we'll see if they make history or not. Polk was also another. James K. Polk was a president that came out of North Carolina. So that answers that. Those questions.
Andrew Jackson.
Andrew Jackson was what?
One.
Wait.
There's 3 from North Carolina.
No. All right, Mrs. G is trying to tell me that Andrew Jackson came. That may be a point of contention.
Union County.
Jackson. Where is this? This is saying that Jackson was born in South Carolina. So and it may be right there on the border, and there may be some contention.
We had
3. I'm sitting here arguing with Mrs. G while I'm recording this, but she thought we had 3, and I'm kind of with her on that. But according to the data, if we're going to trust the data, then we have 2. And so, that, of course, that raises a whole different question. Can you trust the data that you're working with? That's always an appropriate question. All right, so we are done with the birth states. Now we're going to change and talk about the age of inauguration. So they want us to create a box and whiskers. So we're actually, it's probably just easier to kill this one and start over again. I'm going to switch this back to that. We're going to do a new graph, brand new graph. And this time, age of inauguration, I'm going to drop that in that category right there. Now, I'm going to stretch this out a bit so that we can see, where the ages lie. And, they seem to be clumped somewhere in here. This seems to be about the middle, between 50 and 60. And then you've got Joe Biden is the newcomer to the bunch, and he was inaugurated at the age of 78. So you can see that he is a bit of an outlier here. Now we're going to go back and look at that question officially. Does he meet the qualifications for being declared an outlier? Statistically speaking. We'll address that in a bit. All right, so they want to know what is the median age. All right, that's right. They wanted a box and whiskers, so we got to do a box plot. There's our box and whiskers, which tells us that our low age is 42, Q1 is 51, and 55, and 60, and then our top age is 78. So those are the 5 numbers that you get with a box plot. Now, so we've done our box. This is what they want you to screenshot and send. Now they say what is the median of their ages? So this would be the median. This would be 55. So we know that that is 55. And what is the range of U.S. presidents at the time of their inauguration? Well, they went from 78 all the way down to 42. So the range would be the oldest minus the youngest. 78 minus 42 is 36, would be, there's 36 years difference between the youngest president and the oldest one. Now, which 2 presidents did you use to find the range? Well, we knew about Biden being the oldest, but the surprise here is I was kind of thinking it was JFK because I know he was really young. Turns out that Teddy Roosevelt was even younger. JFK was 43 at inauguration. Teddy Roosevelt was 42. So, who was the oldest and youngest? Teddy Roosevelt was the youngest. Biden was the oldest. So, we'll say Teddy Roosevelt at 42, and then Biden at 78. Now, interquartile is a term used to describe the middle 50%. Basically the box in the middle. because when you stop and think about it, this represents 1/4. It's like they took all of the numbers and stretched them out from smallest to largest, and then they said, where's halfway? And so that represents cutting it in half. And then this represents cutting it in half again here and half again there. So we've got quarters. That's why they call it quartiles. Imagine that. So you've got your first quarter down here, second quarter, third quarter, and fourth quarter. So this box represents 2 quarters, or 50%. And it's the 50% that sits right in the middle. So statisticians love studying this interquartile range. They also love studying one standard deviation on either side of the mean. And we'll get to that in a minute. But in any case, let's see now, they want us to find out what is the interquartile range for the US presidents. Well, let's see, Q3 was 60 and Q1 was 51. So IQR equals Q3 minus Q1, which in this case, 60 minus 51, which is 9. So that is our interquartile range. Now, which age is an outlier at the time of inauguration? Well, there is a way of calculating where the boundaries are that anybody that lives outside of those boundaries is considered an outlier. And the method goes something like this. If our IQR is 9, we're going to need 1.5 times the IQR, which is 1.5 times 9, which turns out to be 13.5. Now, what you're going to do is you're going to say, I'm going to start with Q1 and Q3. Now, Q1 was 51 and Q3 was 60. And we're going to take that IQR and we're going to add it here. And we're going to subtract it from the low end. We're going 1.5 IQRs above Q3, and we're going 1.5 IQRs below Q1. And that is going to give us 37.5. So those are the boundaries that I talked about. You know, we asked the question on the timeline, did anybody live at 37.5 or below? Well, I think we remember just a minute ago saying that our youngest president was 42. So nobody lives below 35. But now the question becomes, does anybody live above 73.5? There is somebody. That would be Biden. And so if we are doing a statistical study on this, we would consider this data point right here an outlier. All right, and there are some statisticians which would say, we're just going to remove that from consideration. We're just going to focus on what's left. And the reason they're doing that is because he is so far outside of the rest of the group, an outlier. And so, you know, any number that is shown to be outside of those two windows, you know, we have every right to drop them from the group and just focus on what's left. Now, we're not going to do that today, but there are some statisticians that will do that in a heartbeat. That is what they do. They figure if it's an outlier, then it doesn't really represent the majority, not at all. And if anything, having somebody up here at 78 is going to drag the average up more than it should be. Now, right now, this is the median, which means that at 55, I've got half the numbers, half the presidents above and half the presidents below. We're going to change directions with this in just a second, though. Sorry, so we've addressed the issue of who is the outlier in this statistical group. Now, let's back up and say, all right, this time we're going to talk about the inauguration age, but we're going to create a standard deviation graph with the mean. All right, so we're going to go back here and we're going to get rid of the box plot. We're going to do standard deviation with the mean. And what this does is this tells me that the mean, remember the mean stands for the average. If I were to average these numbers, I would, when we're done with this, I want to show you just for funsies what happens when I take this number out, what happens to the mean. But for right now, this should be the money shot for this question. Because you've got the mean, you've got one standard deviation plus or minus 745, and that was 5549. So we're going to go back to this page and say the mean was 55.49. That's what we just saw, and then the standard deviation is going to be plus or minus 7.45 on either side. Now when I add 745, I get almost 63. And when I subtract 745, I get about 48. So from 48 to 63, remember that plus or minus one standard deviation should be 68% of the data. Now, I'll contrast that with the IQR in a box plot represents 50% of the data, but both of them represent the true middle. And so, both of these have a place in this kind of conversation. You're going to look at both of them and see if there's anything, that one of them tells you that the other one doesn't necessarily. And, of course, that becomes a question of, did I want to include just half the data or did I want to include 2/3 of it? That becomes a question. So, all right, I think we're done with this section. Now the question becomes, what's the shape of the distribution? When I look at this, and I'm going to get rid of these for a minute. When I look at the shape of the distribution, as a matter of fact, let me bring that back on for a second. That lets you show kind of where the middle was and where the middle 2/3 of the group is. And you'll notice that I've got some here on the left, but and some here on the right, and then I got Biden way over here. If Biden were left out, then I probably would have a nice normal bell curve without any shift whatsoever. But throwing in the 78 in the mix skews me to the right. And so this, what's the shape of this? I would describe it as skewed right. If it didn't have the 78, I would probably call it normal. But now the 78 is skewing all of the data to the right direction. I'm really looking forward, because I've not seen until we do it, but I've not seen what the median or the mean is going to look like when we take 78 out of the mix. We'll do that before we finish. But we do want to say that the 78 is causing it to skew right. Because your options are skew right when you've got some extra data out to the right, but not to the left. Or you can skew left, or you can have a normal distribution, which means that it's just perfectly like a bell curve, like it ought to be. All right, so, we're supposed to create a histogram. I didn't do this in class for one of my classes. So let's take that off, and let's group them into bins. Now, I think those bins are not bad. They're 5 years at a time. I don't know that I would have grouped them any differently. So let's go back to this question. Whoops. Determine appropriate intervals for each bin. And I would say that bins of 5 look good. But then you notice that, there's this bell curve going on here, and then there's the extra tail off to the right. That means we're skewing right. So this is going to be the money shot. Well, that's right, they want that, and that's interesting. That's right, you can't do things like box plots and standard deviation when you have histograms. Now, this is one of the points that I made about histograms in the notes, is that when you group them into bins like this, you got them in intervals of 5, and it's like all the other stuff kind of goes out the window. There's not a whole lot I can do with a histogram other than show how they're grouped in bins and, maybe the shape of the thing. But the problem is that, looking at all of these guys from 50 to 55, it doesn't tell me who's 52, who's 53, who's 51. Now, if I hover, I'll get those specifics. That's only because CODAP allows me that privilege. If this were just a pure histogram, I would not know who was 42 and who was 43. Not unless I had the data set in front of me. So this is one of the disadvantages of the histograms, is that it tends to be non-specific with data, especially at times when you need to be specific. So, all right. So we've created and pasted a histogram. We've determined the appropriate intervals. We said, they chose 5, and that looks good. I think I would have chosen 5. All right, and so ultimately we come down to the conclusion, draw at least 2 conclusions about the presidents based on the graphs that you observed. And we're talking about 2 different categories, which means one talks about the birth state and one talks about the age at inauguration. So, when we go back to the birth states, I think I pointed out that you had all of these presidents that came from Virginia and New York and Massachusetts and Ohio. And then after that, no other states had much more than 2. And so, I noticed that New York and Massachusetts and Ohio and Virginia were all kind of in the same area. They're all in the Northeast, a little bit toward the Midwest, but they're all in the same part of the country. You didn't have 5 presidents come out of California or anything like that. And so I think that is an interesting conclusion, that you had more presidents came from the Northeast and Midwest. Technically, Ohio is considered the Midwest. And then when you start asking about their ages, you could say that whether it was, the standard deviation or, the interquartile range, that it had a tendency to go from 50 to 60. So you could say that the majority of presidents inaugurated in their 50s. Oops. Helps if I spell it correct. Between 50 and 60. That's probably a fair statement, is that the majority of the presidents were inaugurated at that age. True, you had some younger, you had some older. And so, this is something that, so long as the data supports your conclusion, I'm going to find a hard time counting it wrong. We're very much at the place to where the data is going to kind of speak to different people in different ways. And so long as the data is supporting your conclusion, I'm going to give you credit for it. This is especially, when we start getting toward the unit test on this, that I'm going to ask you to see what kind of conclusion you draw. And, if the data supports it, then I'll give you credit. This whole unit is about making decisions. And so I have to allow you a certain amount of freedom there, that you can look at the data and see what seems to jump out at you, what seems to be important. But in any case, I think that is the last. Yeah, that's the last of it for this worksheet. And after that, we get into the review sheet.